Hello and welcome to Push to Prod. I'm your co-host Cole and I work on Use-A-Lot, a tool to help SaaS companies build revenue through customer success.
And I'm your co-host, Dan Miller. I'm building a SaaS for the first time and learning as I go. Each episode, we chat about all sorts of things to do with the world of starting, growing, and operating software businesses. And today, it is the 4th of June. It's a grey old winter day here in Australia, but the world is still spinning and we're happy. This is episode number 10. And in today's episode, we're running another Push to Prod SaaS builder session. But first, I thought we might catch up. It's been a while, Cole. What have you been up to?
It has felt like a while, hasn't it, Dan? Now, I know we caught up with Tobias last week, or Tobias, but yeah, we haven't probably caught up in a couple of weeks. So hopefully there's some interesting things been happening on both our sides.
I'm actually keen to hear what you've been up to. It has been a bit. So yeah, what have you been doing, mate?
Yeah, so I mean, we've been at Use-A-Lot, heads down in a bit of, we've got some challenges as you do as a new startup. I think the easiest way to describe it is obviously we built a really, I think, pretty good product that technically could compete against, the big players in the game. We deliberately made that choice. Let's go take on some big companies. The real problem there, obviously, and most people who maybe might be a bit more down the track on this than we are, they would recognise that it's hard to compete marketing-wise when you've got, competitors raising $30 or $40 million and, they have tens of thousands of followers connected on LinkedIn every bloody month, it seems like. And so just there's crickets when it comes to, leads and stuff. It's like really hard to get out there. And we're doing some outbound, deliberate, targeted outbound. But at the end of the day, if our message is we're just like the others, then why wouldn't someone else just buy the others? And so, at the end of the day, we're looking at it, being a bit self-reflective and going, okay, we've got to find a useful niche to gain some early traction. So it doesn't have to be a niche that we want to go in for the rest of our, software lives, but it has to be a niche that the others are not either focusing on it. And realistically, let's be honest, we have to actually be better at them, at that niche. And so we've got 3 that we're thinking of, and we've been doing a number of user calls with that, talking to people, and to be honest, it's probably a good topic for a full podcast to go through some of that.
Yeah, good call.
So that's been the challenge, but it does mean, head out of the code and sort of more into, user chats and brainstorming and a lot of wiki page updates and just recently now building out some landing pages when we're not designers. Like we usually contract that. So now we're going, you know what, let's learn that. So then it's a whole new thing, like learning how our website was put together and getting all that sorted. So it's fun. It's just, I don't know, it's tiring because it's not what I'm naturally good at, if you know what I mean.
Yeah, and at the same time, that's probably exhausting in itself because I find that sometimes if it's something I'm not comfortable with or I'm not used to, it's the activity of doing it is more exhausting than other things. And that's why you want to default to the other things you're more comfortable with, right?
Yeah. And it's this, and again, another topic probably for another podcast, but it is that idea of, you get those opinions of, hire what you're not good at and do what you're good at. And then other people are like, no, hire what you're good at because you can manage it better and take on the things that you should do as a business, whatever whatever that is. As a founder, you should be, you should be good at sales, even if you don't think you're good at sales, that type of thing. So anyway, it's been interesting, but definitely some topics coming up. I feel like I'm brewing through a few topics. We need to talk on this, Dan. Yeah. So what have you been up to?
Well, I have been playing around in the serverless world, and hence the reason we're going to get into that topic today. It's been a bit of fun. Was interested in just, exposing myself a bit more to that world and getting my teeth into it, getting my fingers into it. So I went around and I started playing around with some Lambda functions in AWS and playing around with their API framework and, learning a bit of that. But what it's given me a bit more insight into today's topic. And like I said earlier, I thought today we might be continuing our Push to Prod SaaS builder sessions, the guide to understanding options for building and running and growing your software as a service. So the topic we thought we'd get into today was about opening up the back end and looking at all those infrastructure pieces that make production possible, aka hosting, Cole. That's what I've been up to. So I thought I'd get into that, eh?
Yeah, sounds good. So what parts of hosting do we want to cover? We obviously, there's a number of them.
Oh, mate, it's infinite. So I thought let's zero in here on the topic today. Let's get into the details of really serverless, and in particular, functions as a service. That's where I thought we'd start.
The funny thing here, hopefully people will recognise, I think we're both learning this stuff.
Yeah, that's
so
right.
We've been in software for, I think we're both decades now.
Yep.
I think we're both comfortable, if I can speak for you too, at monolithic type development and back-end stuff. So like I've obviously done a lot of DevOps in terms of setting up some of these things, not so much on the function side. So this is an interesting topic for me. And I'll admit I'm probably going to be asking more questions and giving answers here. So it's going to be an interesting one.
And I'm unashamedly telling everyone that I actually am learning on the go. So, but the good thing about it is everything I'm learning, I'm trying to give back through the podcast here. So hopefully you get a bit of value from it listening in today. So let's start with the main question. What is serverless? Well, it's a category or group of options, which basically means, you, the developer, you don't have to do anything at all with the back-end infrastructure other than just use it. So there's no configuring, no monitoring, no scaling, no spinning up and down, just pure joyful usage. And I reckon it's absolute bliss, well, on paper, from a dev point of view. The reality, maybe not so much the case. That's not maybe my experience.
That was going to be my question, Dan, was, how much is that reality, I guess?
Yeah, we'll find out, eh? Look, the serverless provider in this case, they take care of everything, all the details in the background for you, and you just use it. And you got a few options up your sleeve there when it comes to serverless. Within that category itself, there's actually so many different choices to go through, and we'll mention them here, just a bit of a list. The two main ones that are of immediate relevance to SaaS builders, I reckon, are serverless functions and serverless databases.
Right, so that's sort of pretty much covering then your whole back end and what your front end clients probably need to talk to, I guess, in some sense. Yep, okay, that makes sense.
Yep. Yeah, all the stuff really that your front end's interacting with to get its job done. And if you look at functions as a service, or FAS as sometimes people call them, that's the most well-known form of serverless computing, and that allows you to write and deploy code in the form of functions that you would ordinarily previously on a monolith, you would actually have them in your server code, and you'd have your massive code base, and you'd modularize that, of course. But your functions would be things that you could call at any points in time, whether directly using within your server itself or, accessing it through your API, through your gateway to your client. And some of the more popular FAS platforms that people might be familiar with, or if you're not, here they are. You got AWS Lambda, Google Cloud Functions, you got IBM Cloud Functions. Not that I've used that one.
That one sounds boring.
Yep. Microsoft Azure Functions, Oracle Functions. As you can see, all the big names are getting into it. And then you got the more recent ones, Netlify Functions, Vercel Functions, Cloudflare Workers, and then you've got Dino Deploy and Fly.io. That's the main list that are out. There's plenty more, but that's the big ones that show up.
And so with these ones, Dan, do you know, like what type of languages do you use deploying on these guys? Are they, pretty obvious with something like Azure is that .NET code, do you know, or is that going to be, everything? Like, how do you split this up?
It definitely depends on the platform provider. You can guarantee that over in Microsoft land, there'll be a bend towards the Microsoft stack, the C# stuff and all that. But they also do support, some of our other categories. They do support Node and things like that. I was playing around with AWS Lambda in the last week. And, they got Python on there. You could pick Node. You can pick other languages. But they've got a fair few to choose from, that's the one of the benefits there.
And the other category, I guess we were just talking about, was serverless databases. That's a whole topic on its own. So we'll probably cover that in another episode. But yeah, generally what that is, rather than you hosting a relational database management system or a full, some type of full managed database solution on your own infrastructure, again, you're spinning up a database-like service on some cloud provider, which is taking care of all that. Hopefully, that's the usage of it is all on demand and only charged for the actual usage that you're actually getting out of it. So we thought we started looking at this and going to cover both in this episode, but we thought to keep them a bit shorter and sweeter, we're going to do the serverless DB one on our next episode of the Builder series. So we'll leave that one and we'll just focus on functions.
Cool. And just before we get into the functions, there are like a few others, but we won't get into the details today. There's serverless messaging and eventing. You could do serverless file storage and processing. You get serverless analytics, serverless machine learning. So the concept is really the same. It's somebody else is running that service in the background, and you just consume it, most likely through APIs.
How would a developer, go out and use one of these, I guess, serverless functions or serverless function providers?
Well, this one's hot off the press because I have been doing it. Picture yourself, picture a function that you would typically run in your server layer. So instead of having that function sitting alongside many other functions within a monolith backend, instead you'll take a specific function, just one of them by itself, and you, as long as that's an isolated or an atomic piece of code that could just work on its own with its own inputs, does its own processing and produces outputs, you'll take that function and you'll deploy that onto your Faas provider. And then you'll connect it up with your app via an API. And it goes like this. You'll write the function. It serves a specific purpose within the code. You'll define an event that will trigger the cloud service provider to execute that function. For example, there might just be some sort of HTTP request or a REST API that calls it, and that's the event that triggers it. And when it does trigger it, again, with that, if we continue that HTTP request example, an end user might click something on the front end in the app, right? And then the app goes, excellent, that's the trigger for me to then send that HTTP request down to the provider. It'll go into the gateway and that will trigger the event. What that does then, the function gets executed by the Faas provider, and first it'll check, if an instance of the function is already running. And if so, it'll just use that. If not, it'll spin one up pretty quick actually. The latency is actually pretty small. And then obviously if you picture a traditional function, it'll do its thing, it'll do its processing, and it'll produce some output. And then the way you've structured and built it, it'll send that output back to the client application. It could be just a simple acknowledgement to say, yes, it was a success, or it could be, here's the payload that I finished processing for you and you need to do something with it now and consume it. And, following that example from before, that, the user who did the clicking, they'll see the result of that executed function inside the app, but they won't know it's been done from a serverless point of view. But you, the developer, do. And that's really the basics of it, how it works.
And so when you're doing this, and I'm just asking you questions off the top of my head here.
Yeah, cool.
Obviously the number of functions that you would end up deploying is totally dependent on the type of product you're building. But I could imagine if you went full serverless here and got rid of the server, that there's a lot of functions here that could be.
Oh my gosh. This is something I haven't got my head around yet, but you are absolutely correct. I did it on a real sort of a dinky little scenario, right? I spun up the front end of a marketing site, and I just created a contact form, traditional contact form. Now, normally you could just you could actually just buy an off-the-shelf service these days and plug that in and run your contact form, and it'll send your emails to you. But I decided, all right, here's a good opportunity for me to build the serverless function here, so I'll do it. And I built it, and that was fine. But I'm thinking to myself, my gosh, if I had to do that for just one thing and it took me that long and that's much effort, imagine what it's going to take to do an entire backend. So yeah, you're right. That's probably a bit of a downside.
You might only be originally using these for functions that you expect need this features, which are like scaling, high volume, things like that, or potentially really fast execution because you want to horizontally or vertically scale this thing up. So I guess you probably don't have to go full everything if you don't have to. You could actually combine some of this, and that's what I've done in the past. So we could probably talk a little bit about that, but that probably does segue into, obviously these things are supposed to scale because they're on the cloud. So how does that work?
You hit the nail on the head there. The scaling is probably the benefit, that you'd probably look for functions which at any point in time could be widely variable. There'd be use cases to be put into your serverless function scenario. So what the Faas provider does in those scenarios, they've got a few options up their sleeves for scaling. They could do vertical scaling, and that is where they increase the CPU or the RAM resource allocation to the function. And this is the case, for a complicated function that is very heavy on processing requirements. Or you got the horizontal scaling where you just got a lot of requests coming in. So you might end up having multiple instances of functions that run side by side, and there's lots of them happening all at once. And that might be if there's a burst of activity and lots of separate requests come in from different clients all at once, and you need to smooth that out and handle that simultaneously. So what the service provider then can do is deal with that very, very fast in the background. And that's probably one of the benefits of it. They set up their infrastructure in such a way that it can detect that and handle that situation and then scale up very fast or scale horizontally very fast for you and then spin that down again. And it'll get itself back to an idle state. That's really how it deals with the scaling part of it. And that's probably one of the reasons why you might use it. Yeah.
And I imagine, obviously, you just said it scales down, goes idle. So then hopefully you're not paying for it at that point in time.
That's the interesting part. I did look in a little bit into about how you do get charged, how you pay for functions as a service. And it's a pretty interesting pricing model. There's a few. There's invocation-based pricing. That's every time you invoke the function, right? You get charged based on the number of times that function gets invoked or executed.
Is that like what Twitter's doing with their API now?
That's right. And that's why it's $42,000 a month to use it. It's crazy. But in this case, each time a function gets triggered, that's whether it's in response to an event or the direct API call, that's an invocation. And the cost is typically calculated per invocation. It can vary depending on certain factors, such as how long the thing runs for, how much memory gets allocated to it, and how much network traffic's going on as a result of that. But we'll use an example here. Like let's say you got a silly example. Say you got a serverless function that's invoked, say 100 times a month, and the provider is charging you 1 cent per invocation. Then you'd be charged $1 for all the invocations that month. But in reality, it's probably a lot cheaper than that. Now, they're probably charging something more like, 0.00001 cents per invocation. But that was a silly example for you.
And did you see with that, because you were mentioning just then around, there is some dependent, factors around execution time, memory allocation. What happens if you go over that? Is that a different pricing structure, do you find, or it just like kills your function?
Well, they do have a different form of pricing as well, which could kill you depending on who you go with. Then you've got execution time based pricing, right? So that's the model where they take into account the duration that it takes for your function to complete. Some providers do charge based on the time it takes for the function to run. And that's typically measured in increments of milliseconds. The pricing, it may differ based on the allocated memory again, higher memory configurations or CPU. But if you take that silly example I had before, this time say your function runs for 500 milliseconds and the provider's pricing is, 1 cent per millisecond. Well, on the base tier, if you've got a basic allocation of say 128 megs of memory, that'd cost you about $5 if you're doing 500 milliseconds of work. So again, you could get stung there. You got to watch out.
Yeah.
They do have caps though. I know that some of them all have caps to say your function, if you're running a serverless function, it's got a cap that it has to run within a certain period of time. If you go beyond that, if your function's really heavy and it's got a lot of processing, they'll just cut you off. Yeah, so you got to design.
Yeah, and that's a good safety mechanism then to make sure that you're not actually going to get stung either, and neither are they.
Yeah, and it's pretty handy actually. It causes you to think in units as opposed to monolithic giant blocks, which is always a good practice.
And then you got this. So, I can cover some other ones here. We looked at this as memory-based pricing. So again, I guess it's similar a little bit to the execution one, but now we're just looking at not so much time, but how much memory this entire thing is consuming as it runs. Cloud providers generally charge based on sort of memory size, could be in gigabytes or gigabits, probably, who knows, it would be gigabytes, allocated to run that function. And it obviously correlates a lot with the CPU as well and networking capabilities of that function. So, it's basically you not so much worrying about the time, but going, well, how much grunt, whatever memory CPU do I need for this particular thing? And I'd rather get charged on that. Bit complex to work that one out, so we didn't do any examples on that one.
Next one's happy. This is probably why a lot of people might find themselves getting into serverless in the first case. Free tier, right? Most of the cloud providers, for example, Netlify and Vercel, they've got a free tier, so you can get in there and play around and experiment. You can test things out without incurring any costs, and they typically offer a certain amount of free invocations or free execution times per month. Another one that they do provide is the ability to provide bursting capabilities. So this is where, briefly they can scale up and handle huge spikes in your traffic, and then you won't actually incur any additional costs. And that's pretty nice because most of the time you've got a flat baseline. Occasionally you'll get these peaks, but then I don't know, maybe you'll go and get first placed on Product Hunt and suddenly everyone wants to use your thing. Then you'll get a massive burst in traffic, and that could actually destroy your wallet if you're not careful. So there are providers out there that offer free bursting for you. So look for those. That's always good.
I've had a little bit of experience, not so much with serverless, but I know with AWS's instance types, it's always been this debate for us, at least at the scale we run at, that it's like, I'll probably get a bit technical here, but you got the T instances and then you got like the M instances, and they're both general purpose instances, whereas the T's burst and the M's are just like, well, as far as I understood, are fairly standard. But the T's are cheaper. So it's always this thing. It's like, I've been finding that, if you do get the right scale and you can have a cheaper T instance, but it can burst up memory and CPU up a lot higher than the equivalent, cost that you'd be paying if you had to, pay for that whole thing on an M instance. So that bursting functionality is obviously not just serverless, but it is definitely one of these benefits you get from cloud providers over just running this stuff yourself. It's
nice that they're actually considering it, because in the early days, people were getting stung with that for sure. And speaking of getting stung, there actually are some additional charges you've got to watch out for. They might lure you in with the free tier, but you've got to be mindful. They might also then start charging you separately for things like logging and monitoring and debugging. They might have separate charges. So watch out for that one.
Yeah, well, that's good. So let's run through. So that's sort of the basics, I guess, of, what it is, what the types, how you would actually, get charged, why you would actually call a serverless function in the first place. It'd be interesting to run through what we think are some of the examples, I guess, or use cases for why you'd use it at all. And I think we sort of covered it a little bit just for some of the chats. But what did you find in your investigations here, Dan? I'll let you run through some of the lists, and I'll come in when I find the ones that I've used, I guess.
Yeah, cool. Well, some of them, they do border here on actual different services themselves. But if you just want to think in the world of serverless and some of the use cases for FAS, one of them might be some common web and mobile application backend functions that you find yourself doing. For example, user authentication or data processing or managing file uploads. That's definitely a use case for it. I can see, for example, if you just had the need to do some heavy file processing, you could actually send that through to your serverless, and it could have the necessary resources it does to deal with that for you. You don't have to worry about tuning your own application server to deal with that. You just hand that off to the serverless and let it deal with it. Another one might be just asynchronous processing. This is, for example, if you've got a need to transcode some videos or do some batch processing of uploaded images, that's again another case where you can hand that off to a serverless job and say, there you go, you deal with that. I don't want to know about the requirements in the background of my server configuration. I'll let someone else deal with that.
And do you know, would you be building those functions yourself, do you think, or have you seen in your investigation here, did you see, serverless function providers that allow you to do that? Can I go out and buy not only just a serverless function, but one that's already built to do, say, video transcoding?
There probably are out there. I didn't come across them. The ones that I really came across here were just the raw functions as a service providers, which sort of said, we'll give you the ability.
Yeah, you've got to write the logic or find the library to use it. Yep, that makes sense. Yep.
What else are some of the use cases? You got, webhooks and API extensions. Image, we mentioned this before, like image and media processing. Chatbots is an interesting one. You could actually run yourself a nice little chatbot in the background or some sort of conversational interface using a serverless function.
I think out of those, I think the webhooks and particular APIs are interesting too, because when you go back to one of our first use cases back there, we talked about functions are really useful when you're not, when you're going to get a high load or maybe variable load. And obviously with things like webhooks and API, you're basically giving control to someone else now. It's not even your browser. It's fine. You can almost control when your browser, if you build a client, a front end, you can sort of control how much it talks to your back end, even if you had hundreds of users. But what you can't control is someone setting up a machine and firing API requests into you, or even one of the good use cases here is email coming in. If you process incoming email, you don't know how often someone's going to email that endpoint. And so pushing that off to one of these functions to do that heavy lifting, even storing it somewhere else, and then your your back end is able to then do this at a time when it's able to do it. So I think that webhooks API ones, to me, is a very good use case for this stuff straight out.
And that one you mentioned, email, is what I used in my little investigations there. I built basically a contact form, and you don't actually know how often that's going to get used. So you don't want to be paying for that forever, right? But if you go and build yourself a serverless function, it can sit there and idle in the back. Also, it can sit there and just go to sleep in the background. And then on the odd occasion that some random person contacts you through their form, bang, up goes your serverless function. It spins up, it does its job, sends the email back to your back end or your provider that you need to deal with, and then it winds itself down. So that's another use case for it, for sure. What else? You got a few things there, like, you could do Internet of Things, data processing. You could deal with web scraping. You could deal with data pipelines and workflows, geolocation, mapping services.
Definitely have used that before. Geocoding addresses. So you can sit there and have an endpoint where you get an address in, you can just hit this endpoint, get the lat long, or vice versa. So yeah, very good use case for it.
Beyond these, you can string together a whole bunch of complex orchestrations if you want to. You could sort of say, you've got a 4 or 5 step process, and each one of those is a serverless function in itself. So you'll provide the input at the start, and then function 1 will do its thing, provide its output to function 2, etc. And you could chain that along. For an example there, you could do some sort of user sign up, which triggers a DB update, which then triggers the welcome email. That's a good example there. So yeah.
If you build a microservice architecture, you're heavily using this, but I guess you don't have to. You can do that sort of combination of, monolith, like we said before, and using these functions in some of these use cases in a smart way. So you can sort of dip your toes in.
Absolutely.
Make your full product a little bit more resilient to some of this, asynchronous or random load type events that might come in. But you don't have to worry too much about re-architecting your whole product to go microservice. And
I reckon that'd be a great place for a SaaS builder to actually just dip your toes in the water there. Big architectural decisions they have huge ramifications for you. And if you've already gone down in one direction, changing your architecture for your system is probably a non-starter. So maybe there might be certain use cases in your world where you could say, okay, great, that one there, that function that I know I need to provide occasionally, or that it's got a high lot of variability into how much scale it needs. I'll try that in a serverless function environment and see how that works. Yeah, for sure. On the other side, I don't know if you've heard, but Basecamp, the software platform Basecamp. Now they did build themselves a microservices architecture, and then they decided after a few years, now they're on a scale way beyond whatever you and I might be thinking of. They decided that it just costs them too much money. It's too expensive. So they're going back away from the serverless architecture and more into in-house again. So yeah, it was interesting to see that. So
yeah, and there's more tech, and I think that they've obviously built some tooling around that, not only in the Rails world, but also just in general, to allow you to move some of the. And it's not just them. There is other technology out there that allows you to take what effectively is cloud-based architectures and run them on your own set of servers. So I think that potentially, it feels like I saw a tweet about this. I should have grabbed it. Someone else in the build in public world was almost doing the same thing. Probably not their scale, but bringing it back to bare metal. Which, yeah, I don't know. It's sort of not PC these days to do that.
I reckon one of the benefits, one of the reasons why you would think about it, is the ability to move fast and just experiment with things. So say you and I, or say we're just mucking around one day and we say to ourselves, I think we should build something else that is related to, what we're involved in. I don't want to include that in my current SaaS's back-end infrastructure. I don't want to change the architecture of what I'm doing. I just want to run an experiment. So I'll go spin something up. I'll create a serverless function. I'll connect to it. I'll provide the little front end whatever it is that is going to be that experiment. Connect them all up. Try it out. Away you go. You could actually spin something really fast in that model. And you could do lots of experiments, and quite often, I reckon. So that's where I think this would shine for sure, people that want to move fast.
So I guess what are the other things that you need to consider in relation to, going a full fat, not just a full sort of Faas environment, but just using functions in general. Like one of them we talked about was this cold start concept, and you mentioned it was quite fast in your test stuffs.
Yeah, it's actually not bad.
Yeah. So what are you sort of seeing there? Is that something that you can control? Like if you pay more, it can come up quicker, or is it just dependent on the service cloud provider?
That I don't know the answer to, but I do know that what I have seen is actually pretty fast. Like the latency, and that's something you do need to consider, is the time it takes for when your function goes to sleep, how long it takes for the thing to then wake up once it's triggered. You know, if it's been there for a few days, it's been doing nothing and it's in sleep mode, all of a sudden your first event comes along and it has a little bit of time to get in there. But that what I've observed and what I've read in a lot of the providers is in the form of milliseconds. So it's actually not too bad. I suspect, don't quote me on this, but you'd probably be able to pay more, I reckon, to get that running as a bit of a warm start. So yeah. And I'm sure you could architect certain things yourself behind the scenes to occasionally send a bit of a heartbeat to things, just to sort of say, don't go to, you know, I'm needing you. I know I'm going to need you around these times, so stay awake.
Yeah, start waking up at 5:30 in the morning or something like I am. Yeah, yeah. And then obviously concurrency limits is another one. Conscious of how many you might have to be running, you know, simultaneously, and I guess that would depend a little bit on, you know, the provider and how much that's going to cost and things like that.
Yeah, some of them cap you. For sure.
Do they? Yeah. Or potentially even running different, and we didn't get too much into sort of this edge computing concept, but running these functions in different regions around the world. So therefore, you know, your Australian clients are hitting things close and your US ones are hitting functions that are actually located in data centers close to them. So I guess that's one of the benefits here. Not only being concurrent across, you know, needing it for volume, but also just regionally.
Yeah, I reckon that's actually a good one that we could spin off into another topic, Cole. But for sure, edge functions, that's the concept where, you know, people place their resources as close as possible to where the consumers are or the clients are using it. And in this case, some of these providers actually will limit you. They'll cap you and they'll say you're only allowed to have up to X number of instances in this region. Beyond that, you're going to get throttled. So you got to watch out for that. Speaking of getting throttled, there is the timeout, and I mentioned it earlier. That's the time within which your function must complete before the provider says, nah, game over, and they put a stop to it. They will let your function run up to a certain amount of time and then they'll just cut it off. So you got to be careful about how much you put into these functions. And that's not a bad thing.
Yeah, and the good thing is, I mean, realistically, let's be honest, that's what you should be doing in the web world anyway. Most of your controllers and endpoints in your normal SaaS should be quite fast as well.
Well, there were, you know, even though we've mentioned some of the things to watch out for, there are some benefits. And we mentioned earlier, one of them is cost. You only actually pay for the usage. So you're not paying a per month fee to every single month have the access to the server. What you're doing is you're paying a fee for the amount of time you just use it. So if you've got something running in your SaaS that you're hardly ever using it, but occasionally you do, it's probably not a bad economy of scale there. You could just sort of say, great, I'm only paying about $1 a month to have all these functions running, as opposed to having $7 a month to have the entire server platform as a service running, or even more if you're hiring your own infrastructure. So that's a possibility there.
Yeah, and especially for us, you know, early stage building public people, whatever, you know, like micro SaaS, you know, whatever you want to call these people, our indie hackers, you know, if you've got clients, the first few clients, they tend to be fairly regional. They're around you. So being able to have this thing basically off for, you know, half the day because everyone's asleep, I think is a massive benefit.
And one of the benefits here, you've got is scalability. So that's the automation where your service provider, they'll just spin things up for you. Like I said earlier, horizontal or vertical scale. They'll take care of that in the background as much as you need to, and you don't have to think about it. And I think I like that a lot, actually. Yeah, and that lends itself to the other one, which is productivity. And again, you can deploy code without needing to manage servers, and it accelerates your delivery cycle. You can go fast there. So
yeah, especially if you're working in one of those larger environments where it's great to be able to build up a little web app, but yeah, if you need to talk to IT and this and that to get it deployed, I can see where these things can speed that up. Some of these lead to some challenges, and I guess I'm going to just jump in on that one because the productivity is good, but on the negative side, how do you go about developing now? It used to be that you'd get your IDE up, you got your monolith, you deploy your environment locally. You're running the whole thing on your dev machine. So you can do everything there. Now you've moved everything to a cloud provider. What happens if I've got 5 devs working? What are they working off?
Yeah, challenging. This is what I saw. So I built myself in my own repository on my local machine. I had, a new package in my repository. So then what I did, I started writing the code for the function for the Faas that are there. And it occurred to me very fast. I went, hang on a second. If I want to then run this through an automated testing chain, or if I want to then figure out a way to then promote this through to different environments, like, staging, test, start from the beginning, dev, test, staging, prod, something like that. That's going to be a bit challenging. It's not the normal thing there. You can't just sort of just grab your entire block, promote it and run. You can't just do that. So what you've got to do is you've actually got to then, you can build it locally and then you've got to deploy it. And you can either do that manually or you can run that through an automated deployment chain. But then what that does, it lands over in your Faas provider. And then you've got to build your own environments in there as well. So it's becoming a bit more complicated now to actually chain things together.
And expensive potentially if you've got a lot of devs and they've all got their own versions, different branches, they're working on different features.
Yeah, there's no much, it's not just the same as you would with a single repository base where you're all working together, and you'll git pull and you'll grab whatever's the latest. It's just not the same.
That's the thing. And I have heard, now I'm not an expert at this and hopefully people can correct us if I'm wrong or if I'm right, but I'm not saying it correctly. But I know there is some frameworks like serverless, for example, I think it's called, which can also help you run some of it, I think, locally as well. And sort of like if it's a node environment, it can execute some things locally to speed up that cycle, because obviously pushing it up into the cloud every time just to get a little piece of feedback, that starts becoming very slow for a developer. So I know there is tools around this and things like that, but it is definitely something to think about.
I did see that with AWS. You can actually do a simulated run on your local machine. That's for sure. That is possible. But again, you're adding to the complexity, aren't you? Because you're adding more and more things into your world that you're needing to deal with. Yeah. Some of the other challenges I thought about straight away, I mentioned it before, is that whole concept of testing. That's going to make it a bit more complex. But the two that really got me were the lack of control and the form of security. Again, I mentioned this in the last episode, but you're beholden to whatever the service provider says. If they decide that this is how it's going to work, well, that's how it's going to work. You've got no choice. All you're providing it is a function, and that's it. So if they have issues in the way that there's some sort of outage, or if there's some sort of security issue, or there's some sort of fault on their side, you've got zero control.
I guess that's a benefit of maybe going with the big providers, because if they've got a problem, most of the internet will have a problem. That's been my view of things. It's like, if AWS goes down, well, probably half the internet does. So,
yeah, that's true.
But no, it is true. Like, you are always handing that over. I know with AWS, they have the what's called the shared responsibility model, which is them saying, hey, we are going to commit to, ensuring our infrastructure is X, Y, Z, in terms of reliability and performance, security, things like that. But then you have to do all the other stuff. So it's just knowing where those lines are and being comfortable with that risk, basically.
The last one is just vendor lock-in, really. So once you start getting in there and you're hooking yourself in and all these connections are being made to your architecture, the tentacles are around you. You are in. It's pretty hard to extrapolate yourself from that. So, yeah.
Yeah, it's like that benefit. Like, that's why Kubernetes took off there for a bit in terms of not so much serverless functions, but, because initially the whole goal was, I can run Kubernetes anywhere and put it on any cloud provider and all that. But then you had this other take of people going, hang on, if I go cloud native, it became this cloud native concept, which is like, I'm using 100% AWS components and I get these benefits. And so, but then, yes, you're locked in to AWS. To pull that out and go to Azure, that's going to hurt. So yeah, that's. But as more of these, like I said, as more as these functions as a service have come around, there is more of these tooling that it makes a lot more portable across, especially when, again, I'm not a node guy, but look, let's be honest, nodes everywhere now, and you'd be dumb not to start on that if you're building stuff. It's like, it's becoming a lot easier to transition these across, I think, as far as I could see. And so my next SaaS, even though I've just started one, but not really, because it was a couple of years ago we started writing it, I would probably consider that, and really consider some of these new ways of deploying.
Yeah, it's pretty interesting. Like I said, I like the ability to just do things fast with it. It wasn't my initial experience in the last few days. There's a learning curve, but with that learning curve, it disappears pretty fast. Once you get your head over the concepts and you sort of go, okay, great, I know how this works now. I can see yourself moving a bit faster for the next one and the next one and the next one. But again, it's a whole paradigm switch. It's fine, and if this is what you started learning with when you started building and coding, all the power to you. You're up and running and you know what you're doing. So yeah, not too bad.
No, it's really good. And I've already seen, like I said, the last couple of years, I reckon, maybe a handful of years at the most, this has become so much more mature than where it was, even just 5 years ago. So yeah, excited to test it out. There's a few other little sort of side projects that I've been thinking about. So definitely want to check out some of these new Node ones and Vercel and deploying to that stuff, because certainly some of the frameworks, even that wrap them, just make it so fast to get going these days.
Yeah, absolutely. It's worthwhile trying out. I'd encourage it. I had a bit of fun. I enjoyed the experience. I'd use them again. I wouldn't. I'm probably like you. I still like the whole monolith style. It's just what I'm used to. But I'm quite comfortable now, even over the last few days of just playing around, that I'd go, yeah, this is fine. I get it. I get the concept. It's logical to me. It makes perfect sense. And if I want to just move fast and muck around, I would probably really consider this now for sure.
Oh, cool. Well, we'll update listeners maybe 6 months down the track if we've started using more of these things.
Speaking of listeners, if you've got experience with serverless and with functions as a service yourself, and you've got some ideas or some questions and some thoughts, shout out. Let us know. You can get in touch with us via pushtoprodpod@gmail.com, and we're also at pushtoprodpod on Twitter. We'd love to hear from you.
But yeah, any type of topic that you want us to get into. I think the next couple of weeks, we might start talking a little bit about, the challenges around marketing and niching and positioning and product again. But also a topic that I just talked to Dan earlier about was, should developer or dev founders or technical founders start learning a different skill set, such as design or UX? Can you learn it? If you're a tech head, can you learn to actually be a good designer? I want to challenge that in a positive way. So that would be interesting.
I can't wait. Yeah, I can't wait for that episode, Cole. That's going to be fun, actually. I'm really looking forward to that one. Yeah.
Yeah, no, all good. Anyway, hopefully people enjoyed this episode and us try to sort of fumble our way through learning new functions as a service. I think we both learned something here, Dan, so that was really good.
And absolutely, and don't forget, you can also catch us on Twitter. I'm Mr. Dan Miller and
I'm at Gummo. And until next time, Dan.
Nice one. Well, thanks, Cole. It's been awesome chatting again. As usual, we'll talk to you again next time. Thanks, folks. We'll see you then.